So, good evening, everyone. My name is Rahul. Naam to samay hoga. And what I'm going to do today is we'll discuss the IPM 2019 actual paper. We'll talk about the quant section in that paper. That is the idea, right? Now, in 2019, the quant section in IPM had 60 questions. That is the usual pattern that IPM Indore was following. But because of the lockdown and constraints that they had last year, they had shortened the paper. So before that, what used to happen was the quant section had 60 questions. And these 60 questions were divided in 20 and 40. The 40 were MCQ questions, multiple choice questions. These were short answer type. So for the first 20 questions, you did not have any options. You had to type a key in the answer, the final answer. And for 40 questions, you had options, and therefore you had to choose the right option. That is how it worked. Now, what are the marks that you had to score? Also, when we talk of the IPM paper, there are two kind of students who are attempting it. One who have maths in class 11th and 12th, the others who don't have maths in class 11th and 12th, right? There is a fear among students who do not have maths, where they think that without maths, they might not be able to clear this examination. So factually speaking, the cutoff for the section, right? Here in the 2019 paper was 16 marks. And here it was, I think, 40 marks. Because the marking scheme is +4 - 1, what that translates to is, if out of these 20 questions, you were able to do 4 questions, you would clear the sectional cutoff for this section, right? And if out of these 40, you were able to do 10 questions, you would clear the sectional cutoff for the MCQ part of the quant section. Right? What I would want to do is, I'll be discussing this paper in 2 parts. First, I'll be looking at the short answer type questions, the first 20 questions, and then in the next video, we'll look at the 40 MCQ questions. Also, I'm an engineer, and therefore, I do not know too much. Right? What I'm trying to say is, I'm not comfortable with higher maths part. And therefore, first I will attempt these questions as someone who probably knows maths only till class 10th. From there, once we've done with that, we'll see how many questions actually someone without a maths background can attempt. Will they be able to get this cutoff? And then we look at the rest of the questions to see which were the easy and the difficult ones, which one should have been left, which one should have been attempted. Also, since we are talking about a paper, I will attempt the questions like I would have attempted it in the paper. The idea will be to reach the solution or reach the answer rather than spending time on the solution. Right? Point is, what do you do in the exam is what we're trying to mimic here. So my objective with the questions will be to be able to reach the answer. Right? Also, since it is today we are looking at non-MCQ questions, you understand what I cannot do is I cannot work with the options today, right? So starting with the first question, let's see how you go about it and whether or not. So basically for every question, we'll see which round it is. So what I'm saying is round 1 questions for me from now on would mean questions that can be done with aptitude maths or maths till class 10th essentially. Round 2 questions for me right now are questions which would require knowledge about class 11th and 12th maths. Right? And here I look at easy difficult questions, which one should have been attempted, which one should have been left alone, right? So I'll first run through round 1 questions. I will see the question, we'll see whether it is a round 1, round 2. No, Rudraksh, you should not follow the cutoff system to reach the seat. Not at all. All I'm saying is right now, since this is the first time we are doing this, I want to alleviate any concern that students without maths have. Whether I can get into an IPM, yes, you can clear that paper, and that is what I will show you with over time with all the IPM papers that have happened till now. Right? Of course, I've seen this paper some time. I've not sat down to see, okay, how many questions were there. So that is a surprise for me as much as it is for you. My, my confidence is based on the aptitude part of the preparation that you have been doing, you will be able to get decent marks. So I'm saying, even if I'm getting 4 questions, I'm clearing the cutoff, but this is not what we'll score. We'll score much more than this. I'm very sure of that. Right? Chaliye. So moving on to the first question. I hope the question is visible. The question reads, the sum of interior angles of a convex n-sided polygon is less than 2019 degree. This actually is a 2019 paper as well. Coincidence. The maximum possible value of n is. Now, there is a formula to find out the sum of interior angles of a convex polygon, and you can put that formula and solve, right? But I'm saying there is no real need for that. How do we reach that formula is where I start from. So what I'm saying is, to find the sum of interior angles of a polygon, what we do is we divide the polygon into triangles. That is, if it was a 4-sided polygon, there would be 2 triangles. 4 sides, 2 triangles. If it were a 5-sided polygon, there would be 3 triangles. If it was a 6-sided polygon, 1, 2, 3, 4, 6 sides means 4 triangles. And therefore, the sum of angles of each of these figures would be the number of triangles into 180 degree, right? Now in the question, it says that the sum of triangles is less than 2019. The sum of angles of a polygon has to be a multiple of 180. So I see what is the multiple of 180, that is just less than 2019, right? Now, I know that 180 into 10 would be 1800. Therefore, 180 into 11 would be 1980. 180 into 12 will cross 2019 and it will be 2160. Right? So basically, this question talks about this polygon where there are 11 triangles. My question is, how many sides will the polygon have? If you look at the pattern here, 4 sides, 2 triangles, 5 sides, 3 triangles, 6 sides, 4 triangles. So the number of triangles is 2 less than the number of sides, right? Because there are 11 triangles, the number of sides in the polygon would have been 30. Becomes my answer. I had to write all of this to be sure that, all of us are together. But technically, if I look at the question, all I'm thinking is, okay, 180 into 11 is 1980. So the polygon is 11 triangles, which means it has 13 sides, and that is the answer for me at that point, right? You can always, what you can always do is you can put in the formula, solve for the quadratic equation, you'll still get the answer. So this is question number 1 for me. Definitely round 1 question pertains to geometry, which is something that you would have done till class 10, and a relatively easy question because technically it did not take us time to solve this. Question number 2. Suppose that ABC are real numbers greater than 1, then the value of, again, there is a small correction here. This should read so what this reads is 1 upon 1 plus log of c by a to the base a square b. Sorry. 1 upon 1 plus log of c by a to the base a square b. The next term is 1 upon 1 plus log of a by b to the base b square c. Lastly, 1 upon 1 plus log of b by c, c square. Now, how do we solve this question? Again, it's a log question. Technically speaking, this pertains to the topic algebra. Now, what I would do for a question like this is put values for ABC, right? I could always solve this. What I'm doing is this term I'm writing as 1 upon 1 plus log C by A upon log A square B plus 1 upon 1 plus log A by B upon log B square C plus 1 upon 1 plus log B by C upon log C square B. Now my first hunch was that I put the values of ABC as 1, right? If you do that, you will get 1 plus 1, 1 upon 1 plus 0 by 0. That has become a problem right now, and therefore I'm not doing that. But if I put values of ABC, for example, if I put values of ABC as 2, 4, and 8, right? So here this becomes 1 upon 1 plus log of, this is A, B, C. C by A will be 4. And log of A square B will be 4 into 4, 16. Plus 1 upon 1 plus log of A by B, 2 by 4 will be log of 1 by 2 upon log of B square C will be 4 square into 8, which will be whatever it is. Let's write it as 4 square into 8 plus 1 upon 1 by log of B by C. Sorry for that. Yeah. B by C becomes 4 by 8, 1 by 2 upon log 8 square into 4. Now what I can do is I can always assume that any base. So I'm assuming that the base here was 2, right? Because all the powers are 2. So all of these bases I've assumed that as base 2. So these terms then become 1 upon 1 plus log of 4 to the base 2 is 2. Log of 16 to the base 2 is 4 plus 1 upon 1 plus 1 by 2 becomes minus 1 upon 4 square 8. So this will be 2 raised to power 4 into 2 raised to power 3. So 2 raised to power 7 just plus 1 upon 1 plus minus 1 upon, this becomes 2, 6 and 4. 2, 6 into 2 raised to power 8. Therefore 8. This will be 2 raised to power 4 into 2 raised to power 3. 16, 80. 7. This will be 2 raised to power 6 into 2 raised to power 2. So now solving for this becomes 4 upon 6 plus 7 upon 6 plus 1 upon 7. This is a problem. Okay. Just let me calculate 16, 2 by 4, A by B 1 by 2, 4 sorry, A by B 1 by 2, B square C, 4 square 8, 2 raised to power 4 to 2 raised to power 3, 7, that is all right. B by C is 4 by 8, so 1 by 2, all right, and C square B, 8 square into 4, 8 square will be 2 cube, 2, 6, 7, 8, 2 raised to power 8. So this becomes 11 by 6 plus 1 by 7. I think I've messed up somewhere, but this is what I would have done. Okay. So for the timing, obviously leave question number 2 because clearly I'm not getting the answer. All right. So this becomes technically for me, this is a round 1 question that does not change, but I'm making some errors. So I'll come back to this in the second round that I do. Question number 3. This again pertains to algebra, something that you would have done in class till class 10th, technically speaking. And if you look at previous year questions, you will see that this kind of a question keeps on repeating, where you put values for x and y, then check. Right? But in terms of level of difficulty, I'll also say this is a level of difficulty which probably is towards the difficult level, and therefore this will not be a question that I would attempt in the first go ever. Right? I'll again come back to this. Then is a matrices question. Technically, this is not a topic that you would have done till class 10th, but again, anyone who's done matrices will see that it's a pretty straightforward question. For now, I'm leaving it, but this is in terms of level of difficulty, an easy question. Not really, Sarita. Right? So I will leave this question for now, but this is a question that I will attempt overall. Again, a matrices question. I plus a raised to power 50. Someone who's done matrices will be able to attempt this. I will be attempting this in this session. Finally, a question that is based on algebra, a topic that all of you would have done, actually ratios, a topic that all of you would have done, says 3 friends divided some apples in the ratio 3:5:7 among themselves. After consuming 16 apples, they found that the remaining number of apples with them was equal to the largest number of apples received by one of them at the beginning. So, if the number of apples are 3x, 5x, and 7x, they consume 16 apples, and what they have left is equal to the number of apples that the largest number of apples that one of them received in the beginning. The largest number of apples is 7x. So when they consume 16 apples, they're left with 7x. That means what they have consumed is this. 3x and 5x have been consumed, so 7x is left, which means 3x plus 5x, that is 8x, is equal to 16, which gives me the value of x is 2. Because x is 2, so this will be 3 2s are 6, 5 2s are 10, 7 2s are 14. Total number of apples they had initially, just add them to get 30 as the answer. Right? Straightforward ratios, probably the first or second topic that you would have done as part of your preparation. Not too much of calculation, not definitely a question that you should have done. So question 1, I was able to solve. This is a question that I've gotten an answer for. Question 7. A shopkeeper reduces the price of a pen by 25%, as a result of which the sales quantity increased by 20%. Right? If the revenue made by the shopkeeper decreased by x, then x. Again, this is a straightforward question from the first topic that you do, that is percentage, successive percentage, application of successive percentage change. Basically, price into quantity is equal to revenue. Price, he says, reduces by 25%. Quantity sold, therefore, increases by 20%. What is the change in the revenue is the question. So for a product, if two values change, the overall change is given simply by minus 25 plus 20 minus 25 into 20 upon 100 minus 5 which is minus 10. And therefore, if the revenue decreases by x%, what is the value of x? X is 10. Straightforward question, 3 done. 1 left for my cutoff technically. Yeah, for all real values of x, okay. I look at the question, I'm very sure. Again, algebra question, but not something that I will attempt in my first round, because it looks like a decent sort of a question which will require some calculation. Next, maximum distance between points -5, 0 and a point on the circle x square plus y square is equal to 4 is. Now, technically speaking, this is a class 11th question, but the question is pretty simple. If you know about the equation of the circle, the equation of the circle essentially is x square plus y square is equal to 4 would mean, basically it is x minus a square plus y minus b square is equal to r square. For this equation, a and b are the center of the circle and r is the radius. So if I have this as the equation, that means the circle is centered at 0, 0, because x minus 0, y minus 0. And the radius is r square is equal to 4, which means the radius is 2. So basically the circle is drawn something like this with a radius of 2. I have to find out the distance between point -5, 0. -5, 0 will be somewhere here. And a point on the maximum distance. Obviously, the maximum distance will be of this point and this point. Right? And what will be the distance? The distance from here to the y-axis will be -5, and the distance from the y-axis to the point on the circle will be the radius 2. So therefore, the distance will be 5 plus 2, which is 7. And that is the answer. Because there is no calculation required per se. So this is a question that I would want to attempt. This is question number 9. I think the 4th question that I've attempted. So technically my cutoff is done, and see, I am doing this real time. I am repeating or telling you all the answers. And that this has taken about 20 odd minutes. If you had to do this on your own in an examination, would not take more than 8 to 9 minutes, right? Moving on to question number 10 then. Says x, y, z are positive real numbers and they are related something like this. X raised to power 12 plus y is equal to y raised to power 16 is equal to z raised to power 24. And further says the three quantities, 3 log of x to the base y, 4 log of y to the base z, n log of z to the base x are in arithmetic progression. The question has 2-3 different aspects to it. First is the relationship between x, y, z. You would have done this in ratios. Then it talks about log values. So you should know how to calculate log values. And third, it talks about arithmetic progression. Syllabus wise, topic wise, all of these topics you would have done in till school, right? So basically till 10th. And therefore my round 1 question, I would solve this question because all I have to do is put in values and check for the log values. That's about it. So what I do is I say x raised to power 12 is equal to y raised to power 16 is equal to z raised to power 24. Find the value of x, y, and z in a single variable, right? So what you do is equate this variable to something with a power that is a multiple of 12, 16, and 24. A multiple of 12, 16, 24 is their LCM, which is 48. So what I do is I write this equal to, because IIM talks about cutoff, not the percentile per se, and therefore typically a score of about 200, that is 50 questions, should be good enough in a normal paper to help you clear the exam. And that would have enough margin as well, right? So this is what I write. So if you equate the first and the last, you will get x is equal to a raised to power 4. I divide the powers by 12. If I equate the second and the last, I get y is equal to a raised to power 3, divide the power by 16. And therefore z will be equal to a square. Divide both the powers by 24. So I get the value of x, y, z in terms of a. Plug these values in the given log values. So this becomes 3 log x, which is a raised to power 4, y, which is a raised to power 3, comma 4 log y, which is a raised to power 3, base z, which is a square, comma n log z, which is a raised to power 2 to the base x, which is a raised to power 4. Now I am just trying to find out the log values. We know that log of x raised to power n is nothing but n log x, and log of x to the base y raised to power n is nothing but 1 by n log x to the base y. Right? So if there are powers, the power of the base comes out as a reciprocal and the power of the number comes out as it is. So from here, I'll take out the value. So this will become 3 into 4 by 3. What will be left is log of a plus a, that gets cancelled or becomes 1, comma 4 into 3 by 2, comma n into 2 by 4. This will be 4, 12 by 2 is 6, and this will be n by 2. These three numbers are in AP. So if 4, 6 and the third number in AB, what will be the third number? 4 plus 2, 6. Therefore, this has to be 6 plus 2, 8. And therefore, n by 2 has to be 8, which means n is equal to 60. Again, should I attempt this question in the exam? See, technically speaking, this has some calculation involved and you have to be clear with concepts. But in terms of solving, all I'm doing is putting values and finding out the value. So if you are going to attempt matrices questions, you might actually leave this. If you're not going to attempt those questions, then this is a question that should have been attempted. Okay, the number of pairs x comma y satisfying the equation sin x plus sin y is equal to sin of x plus y and mod of x plus mod of y is equal to 1. Again, the graph of yes, it was. The previous question was time taking, absolutely. Again, sin x and sin x plus y is involved. Sin x plus y is something that you do in class 11. So for now, I'm leaving this question. I will come back to it once I'm done with what questions I have to attempt. Okay, another circle-based question. But now the problem is, in the previous question, it said x square plus y square is equal to 4. I could draw that circle very easily. Here, there is a equation which will have to be converted to that format. Anyone who does not have, again, maths in 11th may not be comfortable with this question, so I'm leaving it again. But I'll come back to it. Again, a matrices question. Technically, we do not know matrices, so we have to leave this. Okay, 14. Let the set this 2, 3, 4, all numbers from 2 to 25 for each k belonging to P. I think this should be let the set P. Define Q of k is equal to x belonging to P such that x is greater than k and k divides x. So I'm trying to first understand what this question is saying, because reading it, I'm not able to understand what it means. All right. So let us try to define Q. Q of k. K is a value that belongs to P and P has, so suppose Q of 2 I define. What will be Q of 2? Q of 2 will be x, where x is greater than k and k divides x. K divides x. So what are the values that 2 divides? 2 divides 2, the greater than. So this Q of 2 will be 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and that's it. So according to the definition given in the question, Q of k means a set of all numbers that are divisible by 2 and greater than 2. So all multiples of 2. Similarly, Q of 3 would mean all multiples of 3. All numbers that 3 divides in P and which are greater than 3. So numbers would be 6, 9, 12, 15, 18, 21, 24, and that's it. So this is what I can keep doing. This is how Q is divided. The question wants to know number of elements in the set P minus union of all values of QK. Right? Again, not a question that you should get into unless you're very, very comfortable with these symbols and are confident of building up a question. Until then, you should not get into it. But if you are following me till this point, see, you have to understand, if I look at all the numbers that will be part of union, that is Q2, union Q3, union Q4, and so on, up till Q25. This will include all the composite numbers, because a composite number will be divisible by at least one of 2, 3, 4, 5, 6, 7, 8, 9, 10, and therefore it will become part of this union, right? What it will not have are the prime numbers, because, for example, if I talk of 2, 2 will not be part of Q2 because x has to be greater than k, and will not be part of anything after that. 2 will not be part of Q3, and so on. If I talk of, say, 7, 7 will not be part of 2, 3, 4, 5, 6 because 7 is not divisible by any of them. And then the value of k becomes greater than 7. So 7 will not be part of it. So what I'm saying is, this will include all composite numbers. If I subtract this from P, I will be left with all prime numbers. And what are the prime numbers in this range? 2, 3, 5, 7, 11, 13, 17, 19, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of elements in the set is 9 becomes your answer. Should you attempt this in the question? Probably not. Not counting this question. Next, the number of 4 metallic tiles that can be produced by melting and recasting. Circular metallic plates. Circular metallic plates are nothing but cylinders. So they have a radius, they have a thickness. If each of the tiles has a shape of right angle isosceles triangle. So basically I have a plate which is being recast into tiles. This is a cylinder. This becomes a sort of a prism because it is being cast into right circular right angled isosceles triangles. So if the sides are x, this will be root 2x. And the circular plate has a radius equal to the length of the longest side. So this cylinder has a radius equal to the length of the longest side of the triangle, which is root 2x. Assume the tiles on the plates are of uniform thickness. Let the thickness is T. There is no loss of material. So how many tiles from this plate? I just have to equate the volume. The volume of the cylinder or the plates would be pi r square into thickness, the plate. And this will be equal to the number of tiles into the volume of the tile. The volume of the tile would be area of the face into the thickness. So this becomes half x into x square into t. I have to find out the value of n because x and t will cancel out. So here I am left with, this becomes 2x square t. So 2 pi x square t cancel is equal to n into 1 by 2 x square t cancel. So this becomes n is equal to 4 pi. Because pi is approximately 3.14, this will become 4 into 3.14, which is 12.56. So how many tiles can be made? 12 tiles can be made completely. Then some amount of material will be left behind. So the answer here becomes, how many tiles are formed in this process? 12. Mensuration basic question. You just have to equate the formula and solve. Should have been attempted. If mod of x is less than 100, mod of y is less than 100, then the number of integer solutions of xy satisfying the equation 4x plus 7y is equal to 3. Now again, algebra question. When you start algebra, you would have done this. We initially talk about solving a linear equation in 2 variable, in 1 variable, things like that. So if I look at this equation and ask you how many solutions are possible, the solutions are infinite. How many integral solutions are possible? Again, infinite. And therefore, a range has been given which says mod of x is less than 100. This essentially means x has to lie between minus 100 and 100. Similarly, y has to lie between minus 100 and 100. That is how you solve a mod, right? Then I'm looking for solutions here. If you have a linear equation in 2 variables, there can be infinite solutions, but the solutions have a pattern. And what is the pattern? The value changes in cross steps of the coefficient of x and y. So basically, I'll try to find out one solution for this, and from there, find other solutions. A multiple of 4 and a multiple of 7 add up to give me a 3. Clearly, one value will be negative, the other will be positive, right? So a multiple of 4, a multiple of 7, the difference between them has to be 3. Any numbers that come to mind? Of course, 7 minus 4 is a 3. So if I make this minus 4 and this is 7, I'll get the 3. So one of the solutions possible is minus 1 and 1. X minus 1, y 1. From here, we build further solutions. For further solution, just add or subtract depending on whether there is a plus or minus between the terms of x and y. Since here, the 2 terms have to add up to a constant value. 2 terms adding up to a constant value. So if one increases, the other has to, if one decreases, the other has to increase, and so on. So either I will subtract the coefficient of y from here, add coefficient of x here, or vice versa. So for the first, I am adding in x, subtracting y. So I add 7 here, minus 1 plus 7 is 6. I subtract 4 here, 1 minus 4 is minus 3. 4, 6 are 24, 7 minus 3, 21. The difference would be 3. Another solution. Keep doing that, add 7. 7 plus 6 is 13. Subtract 4, minus 7. 4 3s are 4 13s are 52, 7 7s are 49, minus, so difference of 3. Again is a solution. Here what will happen is the value of x will keep on increasing and reach 100, or the value of y will keep on decreasing and reach minus 100. Which will hit the 100 first? Because the increase in x is more than the increase in y. And as it is, the value of x is here is greater. X will reach 100 first. Right? So how many solutions will I get till x reaches 100? See, the first term here, 6, is 1 less than 7. Therefore, which is a multiple of 7. The second term is 1 less than 14 and so on. Therefore, the last term or the last value of x will be 1 less than a multiple of 7 as well, because I'm adding 7 to it. Before 100, the multiple of 7 is 98. So the last value has to be 97. Values of x will go from 6, 13, 20, 27, and so on till 97. And correspondingly, we get a value of y. How many solutions? Because this is 7 into 1 minus 1, and this is 7 into 14 minus 1. I have 14 solutions here. I'm treating this solution separately because that is what I use as the starting point for the next or the opposite side of the solution. So I got 14 solutions. Then again, I see 4x plus 7y is equal to 3. One value was minus 1, the other was 1. I have to now decrease x and increase y. So I subtract minus 7 becomes minus 8. Add 4 becomes 5. 4 8s are 32 minus 32. 7 5s are 35. The difference is 3. Again, subtract 7 minus 15. Add 4 9. 4 15s are minus 60. 7 9s are 60. The difference is 3. Solutions satisfy again. Either x will decrease and reach minus 100, or 7 will increase and reach plus 100. Right? Which will happen earlier? Because the decrease in x is more, this will reach minus 100 first. And therefore, how many solutions? The first solution is 1 more than 7. The second solution is 1 more than 14, multiples of 7. The last solution will be 1 more than the multiple of 7, which is 99. How many solutions will be there? Again, this is 7 into 1 plus 1. This is 7 into 14 plus 1. So there are 14 solutions on this side as well. Total number of solutions, 14 here, and one of the solutions is this. Therefore, a total of 29 solutions. Should this question should this have been attempted? Again, if you are preparing, I think this is a question that you should have been prepared for, right? Because again, conceptually it is nothing new. It is a question that you'll keep on seeing again and again. Next, the average of 5 distinct integers is 110. Average question, definitely I'll attempt this question. 5 distinct integers. Average is 110. The smallest of them is 100, right? So if the smallest number is 100, the other numbers have to be more than 100. Once the question asks me the maximum possible value of the largest number. Since I have to maximize the largest number, I will minimize the other numbers. What are the minimum values possible? 100, 101 because they are distinct, 102 and 103. I have minimized the first 4 numbers. The smallest was 100. I add 1 to get the other numbers, and therefore the 5th number can be the largest. How much will this be? Again, you can add all of these up. Take this value as x and say 100 plus 101 plus 102 plus 103 plus x is equal to in the average into 5 and solve. It's a very simple calculation, but I am saying why do that? Here, 100 is 10 less than the average. 101 is 9 less than the average. 102 is 8 less than the average. 103 is 7 less than the average. To make all of these values 100, this number will have to contribute these values to the smaller values. This adds up to 10 and 9. 19, 8 and 7, 15. Therefore, 34. So basically, this number has to have an excess of 34 over the average. So this becomes 110 plus 34, which is 144 becomes the answer. You put in the equation for average, not a problem. Next, assume that all positive integers are written down consecutively from left to right. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. The 6, 3, 8, 9th digit in this sequence. For example, if I ask you what is the 13th digit in this sequence, so the first one digit number is till 9, then 10, 11, 12, 13. So the 13th digit is 1. That is what you're supposed to do, right? Again, a part of number system essentially. This question has been asked in old CAT papers, and if you're preparing for aptitude, you would have come across this kind of a question, the 1000th digit, the 2000th digit, and so on. So what you do is you look at the number of digits in the type of numbers, that is 1 digit, 2 digit, 3 digit, and so on. So if I write all the 1-digit numbers, how many digits do I write? If I write 1-digit numbers, how many numbers do I write? There are 9 digits. Therefore, 1-digit numbers will cover a total of 9 digits, 1 to 9. Then comes 2-digit numbers. 2-digit numbers will cover a total of 2-digit numbers are from 10 to 99, that is 92-digit numbers, and therefore they will have 90 into 2, which is 180 digits. Then comes 3-digit numbers. 3-digit numbers will be from 100 to 999. So there will be 900 numbers, 999 minus 100 plus 1, something that we've done in class. There will be 900 such numbers. Each number will have 3 digits, therefore 2700 digits. So how many digits, if I write all the numbers starting from 1 till 999, how many digits will I have written? 9 plus 180 plus 2700. This adds up to 2889. But I want to reach 6389 digits. Therefore, extra digits required is 6389 minus 2889. This difference comes out to 3500 digits are required. These will have to be done by 4-digit numbers, right? So basically, every number that you write from after this, after 999, will cover 4 digits, and you need 3500 digits from there. So how many numbers will be there? I am saying the numbers will be 3500 upon 4. If you divide this, you'll get 8 4s are 32, 30, 7 4s are 28, 20, 5. So basically 875 4-digit numbers. Are there 875 4-digit numbers? Absolutely, there are 875 4-digit numbers. Which is the 875th 4-digit number? The first 4-digit number is 1 plus 999, which is 1000. The second 4-digit number is 2 plus 999, which is 1001, and so on. Therefore, the 875th number would be 875 plus 999. If you do add it, you will get 4171 1874. And what is the last digit of 1874? It is 4. Therefore, the end of the 875th number, that is 18744, will be the required digit. Should this be done in exam? If you have done it prior to the exam, you might be able to repeat it. If you're trying to attempt it for the first time in the exam, a little bit of a problem, right? Okay. The number of integers of sum are equal to their product is, so there are 2 digits. They have to have the same sum and the same product. I would try to, again, I'll hit and try and see what happens. So if I start from say 3, Now, if these digits are different, say I'm saying x plus y has to be equal to xy. If the digits are different, it will not happen. Right? Because if I multiply anything by 1, the value does not change. If I add 1, the value increases. For example, 1, 2 will be, the sum will be 3, the product will be 2. 1, 5, a similar problem happens. For any other number, the product will be much greater than the sum. For example, 5, 2, the sum is 5, the product is 10. Right? The only thing where this might happen is if I look at something like a 2 plus 2. This happens to be a 2 into 2, and similarly, because they're integers, a 0 plus 0 happens to be a 0 into 0. A bit of hit and trial will tell you that these are the only 2 digits possible. It's a very tricky question because even if you're able to hit 2 into 2 is equal to 2 plus 2, there's a good chance you might actually miss the 0. Right? Also, a similar thing happens with a triplet of numbers, and the only such triplet is 1, 2, and 3. 1 plus 2 plus 3 is 6, and 1 into 2 into 3 is also 6. Right? So for a pair of numbers, it happens for 2, 2, and 0, 0. For a triplet, it happens for 1, 2, 3. In the exam, again, probably should have been attempted. Does not take too much time, but you have to be sure that don't miss out on 0. Last 20th question. This I think is definitely a question that should have been attempted. It's a very basic sort of a question, and anyone who has done number systems or even basic divisibility should be able to solve this. Says you've been asked to select a positive integer n which is less than 1000 such that it is either a multiple of 4 or a multiple of 6 or an odd multiple of 9. So I'll start with this part. Odd multiple of 9. How many odd multiple of 9 are there less than 1000? The first is 9 ones are 9. The second is 9 threes are 27, and it goes on. So basically 18 will get added. 9 fives are 45, and so on. What will be the last such number less than 1000? Again, one is I know that it will be 9 into 111, which is 999. From there, I'll have to count. What I'm saying is a better approach here would be, since this will be an arithmetic progression, 9, 27, 45, and so on, I look at the last term of the arithmetic progression, which is nothing but n plus n minus 1 into d. And I write this as 999. I'll get the value of n here. So this will become n minus 1 into 18 is equal to 990, which will give you n minus 1 into 18, n minus 1 is 55, or n is equal to 56. So first of all, I have 56 numbers which are odd multiples of 9. No multiple of 4 or 6, absolutely. No multiple of 4 or 6 would be an odd multiple of 9. So one part of it is done. Then I look at multiples of 4 or 6. Now multiples of 4 or 6, there will be common numbers as well. How many multiples of 4 first of all? Multiples of 4 would be 4, 8, 12, 16, 20, and so on. The last number, which is less than 1000, will be 4 into 249, because 4 into 250 is 1000. So what I'm saying is, from 4 till 4 into 249, which is 996. This will be the multiples of 4. So I'll get 249 such digits. Basically, I'm just dividing 1000 by 4, or rather 999 by 4. Similarly, if you're looking at multiples of 6, they would be 6, 12, and so on. The last number will be, basically again, for 6, it is 996. And if you divide, you will get 6 into 166. So basically, 6 into 50, 150 is 900. Then for 90, I need 15 more. So what I'm doing here is I'm saying 6 into 150 is 190, is 900. 6 into 15 would be 90, and then 6 ones are 6. So I get 6 into 166 is equal to 996. You would have divided 1000 by 6 as well, not a problem. Now, in these multiples, there will be multiples which will be common to both 4 and 6. I have to remove them because otherwise they'll be double counted. How many multiples of 4 and 6 both? So all multiples of 4 and 6 both will essentially be multiples of their LCM, that is multiples of 12. Right? If you look at the tables of 4 and 6, you'll see that the first common number is 12, then the next common number is 24, and so on. So I look at multiples of 12 then. What are the multiples of 12? 12, 24, and so on. The last number, because see, 6 into 166 is 996. So 12 into 83 would be 996. I double this and half this. So 83 such numbers. So how many multiples of 4 or 6? The number will be 249, plus 166 minus 83. This will be nothing but 249 plus 83. 166 minus 83. This will give you 332. So 332 here and 56 here. So a total of 332 plus 56, which is 388. Again, this is the starting part of number system. Divisibility tests for 4, 6, and 9 are pretty common, and to be able to count the number of multiples should be something that I will be preparing for if I'm preparing for an IPM exam. So this is a question that should have been done. So this is 20 questions. If I look at the questions that should have been attempted by, I think, anyone who is trying to go for this paper, question number 1 was a straightforward attempt. 2, I was not able to do it, so can't count this. 3 I left, 4 I left, 5 I left, 6 we did, ratios questions 2. 7 was a straightforward question, 8 we left. 9 I think was a doable question, I'm not counting it either. This was doable, question 10. Question 11 I've not done. Question 12 I've not done. 13 I've left. 14, again, I would not count it as a doable question. 15th, definitely doable. 5. 16th for me was a doable question. 17th, definitely doable. 18th, again, if you've not done it, you will not be able to do it. So I'm not counting it. 19th, again, tricky question, leave it. 20th, I think I should have done, right? So even if I count the bare minimum, it is 8 questions that could have been attempted by your preparation, which talks about class 10th maths. You don't have to get into 11th and 12th, right? If you are someone who is ready to pick up a few topics of class 11th and 12th, which topic to go for? Matrices determinant is definitely one question that can be looked at, right? So if I go back in this slide, I look at the matrices determinant question. I lost my pen for some reason. Yeah, here it is. Now, this is a straightforward question. You have to find out the determinant value of 2A B inverse C cube B transpose. For a product of determinants, this value is simply given by determinant of 2A into determinant of B inverse into determinant of C cube into determinant of B transpose. It's a straightforward formula. And determinant of 2A is nothing but 2 raised to power order. That is 2 raised to power 4 into determinant of A into determinant of B inverse is nothing but 1 by determinant of B into determinant of C cube is determinant of C cube. Determinant of B transpose is the same as determinant of B. These values are given, so 2 raised to power 4, 16 into 5 into 1 upon minus 3 into 1 by 2 cube. The values are given in the question. This is into minus 3. This gets cancelled out. 16 into 5 into 1 by 8. Sorry, 5 2s are 10 becomes the answer. No heavy concept involved. Straightforward question. If you know it, you will be able to do it. Next says, if A is a 3 by 3 non-zero matrix, such that A square is 0. Again, this is a decent difficulty level question. What I'll do for a question like this is, because a 3 by 3 matrix, I'll find a matrix for which A square is 0. So one such matrix would be 0, 1, 1, 0, 0, 0, 0, 0, 0. Something like this. So if I take a to be this, a square would be 0. Right? 0, 1, 1, 0, 0, 0. So this will be a square being 0. Now just put this value in the given question. 1 plus a 50 would be, I is the identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. I plus a would be, okay, now I am in unknown territory. I add the two matrices, I get 1, 1, 1, 0, 1, 0, 0, 0, 1. This to the power 50. Because below the diagonal everything is 0. If I do find the value of this, it will be something like 1. There will be some numbers here. Something like this. When you keep multiplying, these values here will change. The values at the top will change. The values at the bottom will not, because everything is a 0 here. The diagonal will remain 1. This is 1 plus a raised to power 50. And what will be the value of 50a? 50a will be nothing but 0, 50, 50, 0, 0, 0, 0, 0, 0. So for the given equation, the value becomes, if you subtract these two, this becomes 1, a minus 50, b minus 50, 0, 1, c, 0, 0, 1. We have to find the determinant of this value or this matrix. Clearly, the determinant of this matrix would be 1. No, 3 with that. This will become I answered come out to 1 if I'm not wrong. Right? And only for people who know will this be able to, will I be able to solve this? Then no, 6th is something that we did, 7th is something that we did, 8th I'm leaving for now, 9th, 10th. Again, if I look at this equation, while in the exam, if you have to solve something like this, solving for sine of x plus y may not be the best of ideas, because I do not know what the value is, and therefore, if I come across a question like this, I would probably put values in check. So if I have to get this done, what could be probable values of x and y? Also, x and y have to satisfy. This is what I cannot do is I cannot simultaneously put x and y as 0. If I put x and y as 0 simultaneously, then this equation will not get satisfied. So one is I put x as 0, sine 0 is 0, so sine y is equal to sine y. So this will get satisfied. Right? So when x is 0 for every value of y, this equation is fine. Right? And therefore, if I put x is 0, what should be the value of y which will satisfy the equation here? Y is mod of y is equal to 1. Values of y is 0 and 1 will satisfy. So when x is equal to 0, y is equal to 1, I get a solution. When x is equal to 0, y is equal to minus 1, I get a solution. All the equations are symmetrical. If you interchange x and y, the answer does not change. So one set of solutions will be the reverse value solution, that is x being 1, y being 0, x being minus 1 and y being 0. I have 4 solutions. Now if I have to find another solution for sin x plus sin y is equal to sin x plus y, what can happen is For example, if I put x is equal to minus y, right? So sine of y, or this becomes sine of minus y plus sine y is equal to sine of y minus y. Sine of y minus y is 0. Sine of minus y will be minus sine y plus sine y will be 0. So this is another value which satisfies when I keep x is equal to minus y. What solution for x equal to minus y, or what values of x is equal to minus y will satisfy this equation? So because x is equal to minus y, the absolute values are same and they add up to 1. So either x becomes half and y becomes minus half, or x becomes minus half and y becomes half. Both these values of x and y are satisfied, and therefore I get a further set of solutions. Without really solving, trying to fit in values, these are the 6 solutions that I get. That is where I stop for this question. Again, this is a question which you could have solved if you have an idea of the equation of a circle. So what I can do with this is, from here I can write x square minus 6x nothing but x minus 3 square minus 9. So if you expand x minus 3 square, you'll get x square minus 6x plus 9. That cancels out with the outside minus 9. Y square minus 10y can be written as y minus 5 whole square minus 25. And then there is a k. So this is the equation that I have. And therefore x minus 3 whole squared plus y minus 5 whole squared will be equal to 9 plus 20, 34 minus k. And this is nothing but the square of the radius as per the equation of the circle. Now, what do I know about the circle? This does not touch or intersect the coordinate axes, and the point 1/14 does not lie outside it. So if I draw this circle, it will be centered at 3 and 5, x3, y5, somewhere here. And I draw the circle like this. The maximum radius it can have is just less than 3. So one value I can say that r square has to be just less than 9 so that it doesn't touch the axis, and therefore 34 minus k has to be less than 9, which would mean k is greater than 25. 34 minus 9. I get the value of a from here. For b, I use this 1/4 constraint. Again, if I look at the circle, the point 1/4 does not lie outside it. So either it will be inside the circle or worst case scenario on the perimeter. Right? This is the point 1/4. The center is at 3, 5. I can find out the radius from here. If I use a distance formula, it becomes root of 3 minus 1 square, which is 4, plus 5 minus 4, which is 1. So root of 5. This is 3 minus 1 square root plus 5 minus 4 square root. Right? This is the value of r. Therefore, r square would be 5. If I substitute here, I'll get 34 minus k. R has to be greater than equal to this value. So r square has to be greater than equal to 5. Because this is the minimum radius that you have. So 34 minus k has to be greater than equal to 5, or k has to be less than equal to 29. And therefore b is an included range. A comes out to 24, b comes out to 29. I add them to get the answer. Unless you're very comfortable with circles and how to operate with the equation, not a question that you should have attempted. This is a question that could have been attempted. Says 3 by 3 matrix is filled with plus 1s and minus 1s such that the sum of each row and column of the matrix is 1. So I try to fill this matrix. Like a layman, I just have to write ones, plus 1 and minus 1. The sum should remain 1. So I write plus 1. The next number will be minus 1. So to keep the sum as 1, the next number will become 1. For this row, I put a minus 1 here, so the next number becomes 1. For minus 1, I put a 1. So the next number also becomes 1. Right? Here I would need a 1 for the sum as 1, and here a -1. So if you look at it, this adds up to 1, this adds up to 1, this adds up to 1, 1, 1 and 1. So I get a matrix like this. There are other matrix possible as well if you rearrange 1 and -1. We have to find out the absolute value of the determinant. Just find out the determinant of this value and you should be good with the answer. So this will be 1 into 1 or -1 minus 1 plus 1 into 1 minus 1 minus 1 into -1 minus 1 into 1 plus 1 into -1 minus 1 into 1 minus 1 into 1. So this becomes -2 plus 0 minus 2 and therefore -4. So the determinant of the matrix is -4. We have to find the absolute value of it and therefore the answer becomes 4. Basic knowledge of matrices will help you solve this question as well. Then I think we were able to go through most of the questions. So what I'm saying is, if I look at this paper overall or the first part of it, round 1 wise, I counted 8 questions. There are a few more questions that could have been attempted if, again, depending on the practice. And if you've done the matrices, the matrix and determinant chapter, you can look at least 2 questions that are relatively easy. One being this one, a direct application of the formula, and one being the last one that we did. I missed it somewhere. Just a second. Yeah, this one. So out of matrices, these are 2 questions that could have been attempted. So what I'm saying is, without matrices, you can look at least 8 to 9 attempts if you are very thorough with arithmetic, number system, and basics of algebra. If you have also done matrices determinants, you can look at about 11 odd questions, right? The cutoff for this section was 4. So bare minimum, what I'm saying is at least double the questions could have been attempted. All of these attempts I've done in about an hour. You will have almost, you will have about 40 minutes to solve this. So if you're not explaining it, this could be repeated, right? So the point is, be thorough with the topics that you start with. At least arithmetic, as we go down to MCQ, you'll realize that arithmetic attempt, or doing the arithmetic section properly will help you attempt even more questions. We'll do that in the next class. For now, out of 20, the target could be about 11 questions based on arithmetic, basics of numbers, algebra, and if possible, matrices and determinants, right? So I think that is all I had for today. I hope this has been useful. I'll continue with this in the next class, in the part 2 of the series, where we will look at the 40 MCQ questions. And again, we look at what are the questions that can be done basis pure arithmetic, where you're not getting into higher math, and the questions that you can attempt with a bit of an increase in the higher or some topics of higher maths. All right. So thank you very, very much. It was a pleasure. Bye-bye.